Here's a quick view of the Khan practice sets on arc length. Pretty straightforward. They have an easy version and a tough version. This is the easy version where all you need to do is set it up. You need to know the basic equation in all its forms, the parametric form, and this is the function form with f of x. So that's going to be that the arc length is going to be L is going to be equal to then the integral from the lower bound a in this case to the upper bound b. Can't write my letters. And then it's going to be from the distance formula square root. In this case it's going to be 1 plus then f prime of x squared. All right, and you can do the function plus 1 or the 1 plus the function. It really does not matter because addition is commutative. So we just do it like that, and don't forget the dx. I can't probably write it there, but you can see I've taken the derivative in advance. It's just a little chain rule. The x's cancel like this, and you get 2 over x. That then is squared, and when you do that, you should get 4 over x squared. I only see that down here, so I'm going to go with option D. Hopefully we'll get the sparkles. Yay. Okay, next question. This is similar. Here it is y equals x ln of x. Again, look at these bounds, and it's going to be very, very similar. When we take the derivative of this, we just get 1 over x, but then we have to square it. So it looks to me like it's going to be option A from there to there. Just don't forget to square your derivative. Pretty straightforward stuff. Okay, I'm going to jump to the harder version. That's one that I've teed up for you already just to save time. We started this in class if you were there. This is 1/3 x squared plus 2 to the 3/2. That's kind of a common one in these sort of contrived versions because they often work out. This one does. It's pretty clever. So there's our basic formula, but they're saying, hey, what is the formula for the length, arc length, in terms of k? Don't get psyched out by that word parameter. That's just as saying like one of the variables. This is the thing that determines the arc length. That's its parameter. So I have 1 plus dy dx squared. When you take the derivative, you bring that out front. The 3's cancel. You kick it down a notch. It goes from 3/2 down to 1/2. That is the square root. So you can see I've got the square root here with that 3's canceling. I get 1/2. Don't forget the chain rule. That's right there. That's a 2x. That is an easy thing to forget. Try to make that muscle memory. Then these 2's cancel. I can go to another color here. That 1/2 and that 2 there cancels. I am squaring a square root, so that cancels. But then I do square the x, so that is going to be x squared plus 2 times x squared. When you distribute that in, that x squared in times x squared gives you x to the 4th. X squared in times 2 gives you 2x squared. Lo and behold, that is a perfect square. If you think about it, that's that form right here that you may have seen, you would have seen in your pre-calc days. That's a perfect square. So now the square and the square root cancel, and I have got just the integral of this very simplified thing. When I do my reverse power rule, I get 1/3 x cubed minus x. When I evaluate the 0, it drops off. When I plug in the k, there I have it. That should be my formula. So let's see if we type this in now. I would type in 1 over 3, and then what is it, k? Are we allowed to type a k? And then we do to the 3rd, and then we do minus. Oops, that's not a minus, that's a plus. Just catch yourself on these things, sorry. No reason why that should be a minus. That's a plus, and then k. Hopefully that'll work. Yes, we did it. Okay, good luck everybody.